closing chapter of the war in Europe. Unforgettable moments which must not go unrecorded in our newsreel history of World War II. First, we look back to that momentous day a short while ago when British and Russians linked up near Weissmar. The war was virtually over when this exciting event took place.
How do you do? How are you, pal? You're one of Joe Stalin's soldiers, and I'm pleased to meet you. We've both come a long way together, and we've done it together.
Красная армия очень довольна тем, что наши союзники также били врага, как и мы.
What does that mean, Charles?
Very good.
What does that mean?
Eh?
What does that mean?
How do I know?
How do I?
Well, we can't speak lingo, but we can fight the same way together, can't we?
Yes. Well, all the best, old man. I'm very, very glad to have met you. Very glad indeed.
Благодарим вас за помощь, которую оказали вы нам в войне против гитлеровской Германии.
Thank you very much. We don't understand the language, but we mean the same thing.
The link-up between the Americans and the Russians at the River Elbe near Tolgau marked the climax of the two great advances into the heart of Germany from west and east. It was colossal news, announced on the eve of the enemy's total collapse. And this is how Major General Reinhardt and his staff crossed the river. Somebody called it the Elbe Regatta. On the other bank, a more imposing link-up was effected. The first had been a matter of recce patrols meeting, but now there were generals and flags, with the Union Jack also in the picture, as it most certainly deserved to be.
Vivid German films uncovered by Allied occupation men tell the story of the V-2 rocket through enemy eyes. In a last desperate attempt to escape defeat, German science threw everything it had into the perfection of V-2. Hurtling through the stratosphere at 3,000 miles an hour to fall on London, this was the peak of 15 years of German scientific research. In the early days, so many launchings were faulty that terrified laborers refused to work on the project. Some would spiral crazily up and then plummet down. One of many failures, it crashed on a German airfield, and the dwindling Luftwaffe suffered a self-inflicted blow. Second only to the atom bomb, V-2 was the war's deadliest weapon. It even killed the men who had spent their lives perfecting it.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket. Here, an artist's conception of how the feat was accomplished. A three-stage rocket. Number one, the booster in the class of an intercontinental missile. Its weight estimated at 50 tons. The smaller second stage took over at 5,000 miles an hour and carried on to the highest point reached. 500 miles up, the artificial moon is boosted to a speed counterbalancing the pull of gravity and released. You are hearing the actual signals transmitted by the Earth-circling satellite, one of the great scientific feats of the age.
Прием. Минутная готовность. Кедр. Я Заря-1. Внимание. Минутная готовность. Минутная готовность.
Заря-1, я Кедр. Вас понял, минутная готовность. Занимал исходное положение, занял. Поэтому несколько задержал с ответом. Прием.
Ключ на старт. Ключ на старт. Есть старт. Протяжка 1. Есть протяжка. Продувка. 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 Есть продувка. Ключ на дренаж. Ключ на дренаж. Есть дренаж. Зажигание. Кедр. Я Заря-1. Зажигание.
Понял, вас дается зажигание.
Предварительное. Желаю вам доброго полета. Я Заря-1. Мы все желаем вам доброго полета. Все нормально.
All right, lift off and the clock has started.
Werner von Braun, who is at present the chief of the Guided Missile Division of the Army's Rocket Center at Redstone Arsenal. He was also overall director of the development of the original V-2 rocket.
Now here's a model of my design for a four-stage orbital rocket ship. Compared to the unmanned instrument rocket, it is quite large, but the overall size and weight of the rocket is mainly determined by the 11 tons weight of this top section. This weight dictates the amount of fuel and the numbers of motors needed to produce enough power to equalize the gravitational pull of the Earth. The payload in the top section will consist of 10 crew members plus equipment. Notice the wings, small rocket motor, and landing gears. This is a section that must ultimately return the men to the Earth safely. To produce the energy needed to hurl this stage into the orbit, we need these three additional rocket-powered sections. Here we have a cutaway drawing of our rocket, showing the location of the fuel and the motors of each section. The first stage carries 1,060 tons of fuel, and its 29 motors will lift the entire weight of the ship vertically off the ground. The second stage has 8 motors and carries 155 tons of fuel. It will be dropped when its speed has reached 14,300 miles per hour. The next is our third stage, with only 1 rocket motor and 13 tons of fuel. The third stage gives the passenger section the final kick to attain the orbit. It will not be separated from the passenger section until just before the return flight. The third stage will be left in space, and a very small motor in the winged fourth stage will return the ship to the atmosphere so it can glide back to the base. If we were to start today on an organized and well-supported space program, I believe a practical passenger rocket could be built and tested within 10 years. Of course, it would be foolish to rush headlong into building a 4-stage rocket, man it with a crew, and attempt to fire it into an orbit without first following a step-by-step research and development program. Let's illustrate this with the help of a few pictures. First, we would design and build the 4th stage, and then tow it into the air to test it as a glider. This would also allow the crews to practice. Next, low-altitude flights would be made, firing the small rocket motor in the 4th stage. This would also give the crew more and more training. Following that, the 3rd and 2nd stages would be constructed and tested very thoroughly on the ground, after which they would be joined to the passenger section so that faster and longer flights could be made up to speeds of about 12,000 miles per hour. The only thing remaining would be the building and ground testing of the huge 1st stage. Then there would be no more test flights. When all the sections are joined together, the ship and its crew will be ready for man's first flight in space.
Расцветали яблони и груши, поплыли туманы над рекой. Выходила на берег Катюша, на высокий берег, на крутой. Выходила на берег Катюша, на высокий берег, на крутой. Выходила, песню заводила, про степного сизого орла, про того, которого любила, про того, чьи письма берегла. Про того, которого любила, про того, чьи письма берегла. Ой, ты песня, песня не пишет, и летится ясно солнце свет, и войну на дальнем пограничье, как Катюши передать привет, и войну на дальнем пограничье, как Катюши передать привет. Пусть он вспомнит девушку простую, пусть услышит, как она поет.
Дорогу к ней продолжает осваивать человек. В Советском Союзе впервые в истории осуществлен выход человека из корабля в космическое пространство. Это подлинные документальные кадры. Они сняты 18 марта 1965 года автоматической кинокамерой, установленной на борту космического корабля «Восход-2». Пилотирует корабль Павел Беляев. Вышел из корабля Алексей Леонов. И он живет, работает, улыбается.
For the eyes of the world, now look into space, to the moon and to the planets beyond. Our leadership in science and industry, our hopes for peace and security, our obligations to ourselves as well as others, all require us to make this effort, to solve these mysteries, to solve them for the good of all men. There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind. We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
We monitor our status for it. Firing command coming in now. We're on an automatic sequence as the master computer supervises hundreds of events occurring over these last few minutes. 2 minutes, 10 seconds, and counting. Oxidizer tanks in the 2nd and 3rd stages now have pressurized. T-minus 1 minute, 35 seconds. The third stage completely pressurized. 55 seconds and counting. Neil Armstrong reported back when he received the good wishes. Thank you very much. We know it will be a good flight. Good luck and Godspeed. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6.
At the foot of the ladder, the 11-foot beds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind. As the surface is fine and powdery, I can pick it up loosely with my toe. It does adhere in the fine layers, like powdered charcoal, to the sole and sides of my boot.
That's all, Mark. That max acceleration? No. Man, you are really bouncing.
Is he on the ground at all? 10 kilometers. Ignition. Right away, Houston. Brakes are good. Back start.
5, 4, 3, 2, 1, 0. And we have a liftoff. The Skylab lifting off the pad now, moving up. Skylab has cleared the tower.
Houston is now controlling. Mark, 18 seconds. Pitch and roll program started. Saturn now maneuvering to its proper flight path attitude. Mark, 25 seconds. Mark, 30 seconds.
Apollo Houston, I got 2 messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
All righty, sounds good. Apollo Mila LXing.
Mid-July 1975, an American Apollo spacecraft and a Soviet Soyuz spacecraft prepare to join in Earth orbit, 140 miles above the Atlantic near Portugal. During their 2-day joint flight, astronauts and cosmonauts transferred between spacecraft. They conducted space experiments, and they tested a compatible rendezvous and docking system, evaluating its potential as the universal standard on future spacecraft for docking and rescue.
Madam Carrier aircraft pilot Fitz Fulton will call launch ready after pushover after he's achieved the proper airspeed.
Take one step. Two clear.
Hey, we got a GPC light, lost the sync on 2, pushing over. And a big X on computer number 2. Here coming.
Doors open and they're all down, coming down. Look down here. 50 feet. 40 feet. 30. 20. 15. 10. Holding 10. 220 at about 5 feet. 4 feet. Getting some dust. 4 feet. 3 feet. 2 feet. Just holding off about 2 feet. You're on. You're on. Okay, your nose wheel's about 10 feet. About 5. 4 feet. About 5 feet. 4, 3, 2, 1. We'll see you, babe.
Yes, that's great.
And Gordon. Copied. Touchdown at 54 minutes, 5 seconds past the hour. Belay that, 53 minutes, 51 seconds past the hour with nose gear down at 54 minutes, 5 seconds past the hour.
7, 6, 5, 4. We've gone for main engine start. We have main engine start. America's first space shuttle. And the shuttle has cleared the tower. Back there, roll program. Go.
Roger, roll.
Roll program complete.
Roger, roll complete. Columbia, Houston, your go at throttle up.
Roger, go at throttle up.
30 seconds and counting.
Sequence start.
We are go for auto sequence start. The hydraulic power units on the SRBs have started. T-minus 20 seconds and counting. T-minus 15, 14, 13, 12, 11, 10. We are go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the orbiter Challenger and the 6th flight of the space shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a
program. Houston copies, Challenger.
Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up. Roger, go at throttle up.
Standing by for solid rocket booster separation.
SRB-7, was that something?
We mark the unofficial touchdown time at 5 days, 0 hours, 23 minutes, 42 seconds.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Roger, roll, Challenger.
Good roll program confirmed. Challenger now heading downrange. Engines beginning throttling down now. at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles. Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Roger, go at throttle up.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9
And we have a go for auto sequence start. Endeavor's onboard computers have primary control of all the vehicle's critical functions. T-minus 20. T-minus 15 seconds. 12, 11, 10, 9, 8, 7. We have a go for main engine start. We have 3 main engines running. 3, 2, 1. And have main engine cut off. GLS safing is in progress.
Pass 101, DFS motor to 102, LED shows 1. Headed to USB, 4 miles LS 4. GLS station is in progress. Copy, launch team, that's page 909.
We have a cutoff of the main engines. The countdown clock has stopped.
CDR, perform DFS safing. And NTD, GLS safing is inward. Ignition septics are safe. All engines are in post-shutdown standby. GLS is go for orbiter APU shutdown. And we have no MPS fire detectors tripped at this time. Copy.
7, we have a go for main engine start. 5, 4, 3, 2, 1. We have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
Houston now controlling the flight of Columbia, the international research mission finally underway.
Roger, roll, Columbia.
The Space Shuttle Columbia was going over North Texas. You're looking at a live picture now of Mission Control. And this was the shuttle going over North Texas. At the time, it looked like a normal re-entry because the shuttle would normally light up in re-entry because of the heat of the friction of the Earth's atmosphere. But then we began to see this.
If you'll notice here, it looks like you can see pieces of the shuttle coming off.
Pieces of the shuttle coming off, and NASA, we can confirm that the shuttle is behind schedule. It was to land in Florida. There you see
6,
what appears
4, 3, 2, 1. And liftoff of Space Shuttle Atlantis. A final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Bypass across the board, Scooter, no action.
Houston now controlling Atlantis on its way.
GLS, go for auto sequence start.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T-minus 17 seconds and counting. 15, 12, 11, 10, 9, 8, 7, 6. Go for main engine start. Main engine start. 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
9, 8, 7, 6. All 3 engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis on the shoulders of the Space Shuttle. America will continue the dream.
Program, Houston.
Roger, roll, Atlantis.
Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. 54 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 40 seconds into the flight, the The 3 liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time.
Работают нормально. 20 секунд, двигатели первой и второй ступени работают устойчиво.
Nine, 8, 7, 6, 5, 4, 3, 2, 1, launch.
Right now,
Engine
150
shutdown.
meters per second. Slightly below nominal. We're over 1 kilometer. Trunk deploy. Drugs look good.
Full duration.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.